Welcome back, everyone. We're going to be solving LeetCode 559, maximum depth of an N-ary tree. So we're given an N-ary tree, we need to find its maximum depth. The maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. An N-ary tree is an input serialization is represented in their level order traversal. Each group of children is separated by the null value. Okay, so this is pretty similar to finding the longest path or maximum depth of just a regular tree, where we used either a depth first search or a breadth first search to count the number of nodes from the root all the way down to the leaf nodes, right? So example 1, they give an output of 3 for this problem, right? We can clearly see the root is at level 1, and then we have 2 other levels before we get to the deepest level. So we can do, I'm going to solve this problem using a breadth first search. So I'm going to import the DQ from collections. Import DQ. So we'll set that up real quick. Q is going to be equal to DQ. And we are going to put now we're going to be doing something similar to what we did with finding the maximum depth of just a regular tree, where we're not only going to put the root on our queue, we're going to put a tuple of the root along with its current level. And every time we move down a level, we're just going to increment the levels, and then we will return the node in our resulting array, the very last one of its level. So we will say the root will start at level 1. We're going to have a resulting array. Now, we are going to loop through, right? We need to touch every node in this tree. So we have to say while our queue still has items in it, so while the length of our queue is not equal to 0, what do we have to do? We have to grab that node that is in the queue. So we can say the node and the level is going to be equal to queue.popLeft. Right, breadth first search goes from left to right. That's why we do pop left. Now, what we need to do is check. Okay, so if our node is not none, we know we can append the node and the level to our resulting array. So we can say res.append. Again, we're going to do a tuple, and it will be the node and the level. Otherwise, what do we have to do, or what do we have to do after we check this? We have to check for children, right? So now let's check for if node.children is not none. What can we do? Well, we know it's an array, right? So what we're going to do is we are going to pop each item off of this array and add it to our queue. So we'll hit 1. It starts in our queue, so we take that off. We add 1 and the level 1 to our resulting array. We move down to the second level. We grab this 4. We put 4 into our queue along with its corresponding level, which is going to be 2. And then we do this while we still have children to pop. So we'll say while node.children is not, or while the length is not equal to 0, we're going to run this loop. So while the length of node.children not equal to 0, we want to say queue.append that child. So we can get the child. You can either do node.children.pop right in here, or if you wanted to, you could say the new node is going to be equal to node.children.pop, and the level is going to be equal to level plus 1. And then we can just append the new node along with the new level to our queue. Okay, perfect. So now let's print out our resulting array so we can see what we have. Invalid syntax, if node is not none. Okay, perfect. We have our resulting array with our node and the corresponding level. So, and if we wanted to see this instead of the node object, we could just put node.val on here. And let's see, okay, we'll rerun this so we can get a better look here. Okay, so our root node is going to be on our resulting array first with its level, right? 1, 1. Okay, that looks right. Now we move down to the children. And the child element of 4 has a level of 2, right? That looks good. 2 should have 2, which is right here. 3 should have the level of 2. Perfect. Now we move on to the next level. 6 should have a level of 3. 5 should also have a level of 3. So now what we can do is we can just return, we can grab this last item in our resulting array and then grab the first index of this item. That'll give us the level. So we can just return res of -1, right, that last item. Now we don't want the 0th element or the 0th index, we want the first index. So we say res of -1 of 1, and that should give us our answer. So let's run this. Perfect, pass both test cases, we'll submit. And looks like I forgot the base case. Okay, so if we are given an empty tree, what do we return? So if root is none, what can we return? We can just return, I think they want just an empty list. No, they want levels. So we can return, if we don't have a tree, we should return 0, right? Okay, we'll run this. Perfect, submit. Awesome, so it does pass. So time and space complexity. Space complexity is going to be bound to the length of our queue plus the length of our resulting array. So it is going to be O of the queue.length plus res.length. The time complexity is going to be, well, it's O of n to traverse every single node in our tree and place that node along with this corresponding level into our resulting array. But we're also iterating through the array of children. So we are touching every node, well, we're still touching every node once, but this is going to be an O of n times m solution. So n is going to be the length of nodes, m will be the length of our children array in this case. All right, that'll do it for LeetCode 559.